In this video, we are going to see various methods of solving systems of linear equations. We all know how to graph the two lines if a system consists of just two equations, or even if it is three equations. We know how to graph it and then find the point of intersection of the planes or the point of intersection of the lines, and that will be our solution. So in this case, when we are trying to graph the two equations y equal to 0.5x plus 2 and y is equal to negative 2x minus 3, we have the point of intersection as negative 2, 1. This method will be useful when we know that the point of intersection is approximately going to be an integer, or if we can have a graphing calculator to graph it, maybe you can also try to get the point of intersection of the two curves. The next method is a substitution method. In this, in order to solve these systems of linear equations, let us substitute the expression of either y or x, which we calculated from one equation, substitute in the second equation and try to find the second variable. For example, in this system, 3x plus 2y equal to 16 and 7x plus y equal to 9, we can get y equal to 19 minus 7x from the second equation. Since we are able to get the value for y from the second equation, you can substitute this in the first so that you get an equation only in terms of x, and you can solve for x, and x is 2. Plug in this value of x is equal to 2 in the first equation, second equation, or the equation what we took, y equal to 19 minus 7x. That gives you the value for y as 5. So the solution will be 2, 5. The third method is called the elimination method. In this, you are going to make the coefficient of either x or y to be the same by multiplying or dividing, adding and subtracting. You are trying to eliminate one variable and you try to get the value of the other variable. Say if you are eliminating 1, if you are removing this x variable, maybe you can get the value for y and plug in this value of y in any one of those equations to get the value for x. In this example, the coefficient of x is 4 and the other equation, the coefficient of x is 8. So you're multiplying the first one by negative 2 so that becomes negative 8x, so that you can add them together, or you can even multiply that by positive 2 and subtract one from the other. So in this case, we have multiplied by negative 2, so that the first coefficient is negative 8x and the coefficient of x in the second equation is positive 8x. You add the two equations, you get rid of that x, you eliminate x. So you get an equation y in terms of y. Solve for y is negative 2. Plug in this equation, this value of y in any one of those equations. So your first equation is 4x plus 3y. In this, y is negative 2. So you get x equal to 1, and that will be the solution. So the fourth method is called the Cramer's rule method or the determinant method. In this, we are considering the determinants of the augmented matrix. The augmented matrix is A1, B1, C1, A2, B2, C2. If you just take the coefficients of x and y and treat that as a determinant, that is my main determinant D, A1, B1, A2, B2. It is a 2 by 2 determinant. The determinant of the matrix A1, B1, A2, B2. And the other one, dx, will be, we'll remove the coefficient of x, that is A1, A2 are replaced by the constant C1, C2. So you have the determinant C1, C2, B1, B2, and that will be our dx. The same way dy will be removing the coefficient of y and replacing that by the constant C1, C2. You get A1, C1, A2, C2 to be dy. So x will be dx by d and y will be dy by d. For example, in this to solve this equation 12x plus 3y equal to 15 and 2x minus 3y equal to 13 using the Cramer's rule, we have this augmented matrix 12, 3, 2, negative 3 and 15, 13. So this coefficient of x 12 and 2 will be replaced by these constants 15 and 13 here. So we have the determinant 15, 3, 13, negative 3, and here we have the determinant of the main D, which is the coefficient of x and y, 12, 2, 3, negative 3. When you simplify, you get that as 2. The same way for y, you can find dy divided by d, which is the determinant of 12, 15, 2, 13, and the determinant 12, 3, 2, negative 3 will give us negative 3, and the solution will be 2, negative 3. So the fifth method here is the Gauss-Jordan's elimination method. In this, we are trying to reduce this to a row echelon form. The row echelon form is the first element here must be 1. So we are trying to reduce this in each step, and then we are trying to get a unit matrix here, which is in the reduced row echelon form, and then the last column here will be the solutions. X will be 3 and y is equal to negative 1. So the Gauss-Jordan's elimination method is clearly explained here. The same Gauss-Jordan's elimination method can also be obtained using a graphing calculator. So the reduced row echelon form of matrices using our TI-83 or 84 calculator, which is our method 7, will be the easy method of solving any system of equations. The system can be of 2 variables, it can be of 3 variables, 4 variables, or even 7 variables. So how we do is enter all these coefficients, augmented matrix, that is the coefficient of x, y, z, and the constants using the matrix. So select your matrix in your graphing calculator. Under the matrix, you have to edit. Suppose if it is here in our case, it is 3 by 4 matrix. There are 3 rows and 4 columns. So using the 3 by 4 matrix, you can enter all those values. And then again select Stat Math. Search for reduced row echelon form. In your reduced row echelon form, if you enter this matrix A, then you get this reduced row echelon form of it, which is nothing but the unit matrix. And the last column what we get are the x, y, z values. So now here, since it is given in decimals, you can try to get the answer in fractions also. You just press math, move your cursor to fraction, and then enter. Math, your answer is in fractions. So all these answers will be given as a fraction, and your solution will be negative 7 by 8, 3 by 4, and 9 by 8. So in this video, we learned about 7 different methods of solving systems of linear equations. It can be a graphing method, substitution method, elimination method, Gauss-Jordan's method, reduced row echelon method, or you can even use your TI graphing calculator to get that result. Hope this video was helpful. Thank you for listening.